Okay, welcome to the first of hopefully many monthly SubAligner Q&A sessions. I thought about calling it the SubAligner Users Group or, Alignment Wizards or something more fun like that. Maybe we'll think of a better name. Um, Actually, the first question I have for you guys is what would be the best day and time for this if I did it, say around the beginning of each month? What is the best day of week? So if you want to just type in the chat like day of week and time and put your time as a relation to now. Like is now a good time or is, 8 hours later a better time for you? I know a lot of people are off, on Mondays, people that do concert sound or theater and work at, churches on or houses of worship on Sundays. But maybe a lot of you would prefer a weekend time or a Friday time. Let me know. I think Mondays are usually pretty good. Yeah, or maybe Tuesdays. A lot of you are saying that now is good. Of course, you're here. I guess now worked for you. I guess this isn't an accurate poll, so we'll have to do more later. Okay, so I'm going to share my screen just so we have you see a little bit of the agenda here. So I talked a little bit about how these are open to everyone, and I'm happy to see you guys. And also just a quick warning that they are going to be recorded, and I hope that's okay with everyone. And the benefit is that you'll get to come back to it later as well. There'll be a transcription. You can search through it, like, oh, what was that thing that I said that made a lot of sense? And I thought it'd be fun to do some quick introductions. So just in, like 30 seconds, if you want to say where you are in the world, what kind of shows you work on, I think that's all really interesting. So, for example, I'm Nathan Lively. I'm your host, and I'm in Minneapolis, Minnesota. I mostly work on corporate events, and I'm also the founder of Tracebook and SubAligner. And I will be in Le Mans next week for the AES Sound Reinforcement Conference. Is that what you call it when it's an academic thing? And so I don't know if you're in France, and you're going to be there. I would love to see you. And then I'll put my links in the chat. Yeah, so I'll just go down the list. So Steve, do you want to introduce yourself?
Yeah, I'm Steve. I'm in balmy, warm Canada. It's very cold today, even though I'm on the West Coast. I work full-time for an artist that does a rock/mental health presentation. We play for high school kids. We play performing arts centers in B-size arenas. And I work for the major sound company out here in Vancouver. So I'm freelancing when I'm not doing that. And I work for the charity full-time also. So lots of stuff on the business side. And always always ready to learn more about alignment. I come from studio world, so the piece of the puzzle that I'm working on very hard is wrangling PAs better than I have been, and just trying to learn about that every day.
Yeah, and Steve put his LinkedIn link in there. You guys should connect with him. And he also has his own YouTube channel, and he does his own like teaching about mixing and especially a lot of studio stuff. So I recommend that you check out his stuff. Ed, who are you? Where are you?
Hey, my name is Ed Willock. I am in Grand Rapids, Michigan, originally from New York. Only been here for a short time and dealing with lots of snow currently and cold temperatures. I work a lot in corporate AV, doing A1 and V1 work, and then do concerts in the summer. That's kind of how I keep myself busy and keeping up with varied work. So, yeah. I dropped my LinkedIn also in the chat earlier if you guys caught it.
Cool.
And should we connect you to AV Educate? I feel like at one point you were part of the core team there, or
yeah, and I still am. So yeah, I was the host during the pandemic of a show called AV Tech Talks, which was presented by AV Educate, which is an organization that you know gives stagehands the skills to move up to be technicians, and technicians the skills and knowledge to move up to be engineers and operators. So
Cool. All right. So next on my list is Jim. Jim, are you able to unmute and talk? Okay, great.
Yeah. Yeah. Hey, my name is Jim Mackey. I am from Abilene, Texas. Quick rundown. I've been doing music or audio since 84, 85. In the 90s, worked for a touring PA lighting company as a lighting director. Started learning audio, then also wiring, cabling the whole PA, monitor rig, stuff like that. Fast forward, had kids, got married, got off the road, took a sales job. Been in sales for the last 20 years. Started my company up about 5 years ago, and it started to take off here lately in the past 2 years. I've done a lot of freelance work as an A1 tech for Miller Pro Audio. Locally, I do PA and lighting for various acts, various locations, event centers, stuff like that. Just trying to learn more about. Just trying to get the most I can out of the PA system, and I think we've got an RCF rig and a JBL rig, and I think I just got smart, V9. So I think the time alignment and tweaking the system as much as possible to get it to sound as well as it should. So I think the SubAligner will help that, and always eager to learn new stuff. So
Great. Good to have you here, Jim. And I'll point out that I think a lot of us here, or at least I meet a lot of people like me, like you guys, who do all the jobs. Like you're setting up PAs sometimes. You're just A1 sometimes. Sometimes you're doing every job. Sometimes you're doing this. And so I really sympathize with this position where we need to be competent in so many different roles. And so that's why we're always kind of like trying to stay up to date, trying to figure out, are there ways I can do this part of the job better or make this job easier? I was talking with Ed last week about, when he has time off, he's trying to train himself and like, now's like the little time that I have in between shows. Do I need to upgrade anything so that the next run of shows that I do are easier? What are people doing for RF now? What are people doing for art, for alignment now? Like, can I make those incremental improvements? Okay, so next is Jonathan. Hey, Jonathan, where are you in the world?
Hey, hi everyone. I'm in New York, actually in upstate New York. I'm working for a company called WSDG, Walter Stark Design Group. We're an acoustical consultant. We work on projects actually around the world. So it gives me access to a lot of really cool different projects. My background is in live sound and post-production and recording studio. So kind of putting them all together. And I get the distinct pleasure to do some system tuning. So for small and medium venues, and also recording studio calibration and tuning. So I'm trying to piece those two worlds together. And Nathan, your stuff has been super helpful. I've been checking it out for the past few months. Yeah, learned some really great things to nail sub-alignment, phase, all that kind of good stuff that I just couldn't figure out from other sources. So glad to be on here.
Sure. I think if it's the same WSDG that's been around for years, I think when I was
1969.
Yeah. Okay. So when I was in college,
I'm not
someone
that
came
old.
from WSD, right? Someone came from WSDG to speak to my class in college, in my recording school.
It was probably
And
John Storick.
yeah,
Yep, that's my boss.
that's him. Cool.
Yeah, his
So
first
is he
studio,
still doing the same stuff?
he's still doing it. About 3,500 recording studios later, that's at least his number that he says. And his first studio was Electric Lady. So he's been
Amazing.
doing it for a while.
Okay. Great group of people. Glad to have you here. Okay, we did this. We did this. So just to, you know, this topic today of first steps is not super exciting. We'll get into more like maybe exciting topics later, but I want us to sort of all start from the same place. And to start from the same place, I think we need to kind of all agree on the problem and the solution, or, you know, not all exactly, because, you know, there are a lot of funny stereotypes about how sound engineers all have different ways of doing things. And honestly, that's one of the great things about it, right? Like, it kind of sucks that we kind of have a lack of standardization, maybe in terms of methods and the way things are taught. But then that's kind of a breeding ground for creativity. So sometimes you meet people who are doing something in a really weird, different way, and then you can take something away from that for your own workflow. But the main thing I want to talk about today is synchronization. We're just going to talk about this simple question of when sources are separated by distance and therefore they're not arriving in time at the same place, how do we deal with that? And so if I just drew like a really simple picture to represent the problem we're talking about, it's like if you are this little guy standing here and you've got one source here that's closer to you, and you've got one source here that's farther away. This source here, let's call this, can I just write here? Let's see. Hide floating mute controls. We just call this 1, and we call this 2. Then number 1 is going to arrive before number 2. So the most common solution for solving this problem is delay. So we say, hey, source number 1, can you actually wait for a foot so that this guy has time to travel? And then by the time this guy gets to here, maybe I can do another colored arrow if I move some faces. By the time this guy gets to here, then you can go, and then you can both go together. So then we'll be traveling together, and then we'll both arrive at the listener at the same time. Another way to say that is that we can use delay to sort of, from this person's perspective right there, kind of push this guy back so that he's actually over here. So that is the general problem, and this then takes 1,000 permutations where we have front fills, side fills, relays, delays, all these different kind of things happening because one speaker is never enough, right? It'd be nice if we could just put up one speaker or one source and have that one microphone, you know, to cover the entire band, and then one speaker to project that sound for the entire audience. That would be a pretty small audience, though. You know, it's pretty rare that we ever put up a single speaker, right? There's almost always 2. We have to break up the audience because it's too wide. Then we have to break up the audience again because it's too deep. So then we start running into this problem of synchronization. In its worst case, you hear something that's so late in time that it sounds like 2 sources. And if you've ever heard a really bad echo, or we've all been in places that have really strong echoes, those reflections can arrive so late that it really affects intelligibility. So that's the biggest problem. So we just need to make it wait that long. But then we get into the more arguably, debatably minor effects of then summation when things are not so far off that they don't sound like an echo, but far enough off that they're creating comb filtering. And if I'm ever saying words that any of you don't understand, please just speak up, because I'll be looking at the chat sometimes, but please just jump in and or if you want to, refine anything that I'm saying or share anything, please feel free to jump in. But just some real basic stuff here on what is this problem we're dealing with and how do we commonly solve it. So what do we typically do? Well, let's say you had no tools or whatever, and we're just it's our first time setting up a sound system, and let's say that there's a very big distance here, and so there seems to be some problem. Oh, I can tell because when I walk around, I can start to hear that this one is arriving late. Okay, so maybe you think the thing to do is to add some delay. Well, how do you figure out how much delay to add? And so we're going to be talking about that, because you could just start playing around with it, right? And you might just discover through turning knobs, okay, as I start to add delay, then this moves back and I can hear it start to come in alignment. Great. But then it's hard to get it exactly right. There seems to be like this phasing thing that's happening. And so then you start wondering, is there a more accurate way to do this? Any questions or anything people want to add to this, kind of simple topic of what the problem is in terms of, basic synchronization of sources? Okay. In that case, then let's take a step into the tool that we're talking about here, which is SubAligner. So a lot of you are going to start out on this page, the SubAligner homepage. And then you'll click this link here or this link here, and that'll take you to this login page. And new users have to register. Hopefully that's clear. But if you tried to just type anything in here, then you would just get an error. So you go to this registration page, you fill this out. A lot of you guys know you've signed up for a million sites, so you all know how this works, but I just wanted to walk through each of these steps quickly. For new users, just mainly be careful with how you type your email address in. I don't do a double opt-in or anything. I don't make you go and check your email and click a link and confirm that it's working. This may be a bad idea. This may be a thing I should change later, because sometimes you could accidentally make a mistake here and you type your email address in and then you accidentally put a Z instead of a Y. And then you're logged in, but you can't get a password reset. You can't, sign up for a subscription correctly. And then it kind of causes problems down the line. And now I can go in and fix that, just kind of drawing your attention to one potential pitfall here. Of course, this is all easier if you just click the Google button. I've noticed that a lot of people don't like to click the Google button. They think that maybe somehow that gives me access to your email or your security information. It doesn't at all. All this does is it asks Google, is this person who they say they are? And then it sends me back your email address and your avatar, in photo, if you have one, and your name. That's it. And then I store it. And so I just use this all the time because it's a lot faster. Today, I'm going to log in with an email address because I created a new account. So it would look like a new user. So I could show you guys what that looks like. Okay. So the first thing that most people do when they get logged in here is ignore all of this. But I've been making this bigger and bigger so that people will stop ignoring it. I know that everybody wants to just click around and figure it out. And so that's also fine. I'm not going to say anyone's bad or wrong for doing that. But one of the potential pitfalls with this app is that it shortcuts a lot of years of learning. Because what a lot of other people are doing is they go and maybe spend a lot of money on an audio analyzer. And then you got to take a class about that. and then you got to do a lot of learning in the field and experience. And then a few years later, you come back and you get to this point where you can do what we're doing in a few seconds here with SubAligner. And so I've tried to insert some education in here, so that it's all still, there's a lot of magic. There's a lot of stuff that I'm doing here for you, but there needs to be like a little bit of learning at the same time, so you kind of understand how things are going. Okay. So number one, bookmark this page. Why? A lot of people don't understand what a web app is. So yes, you're accessing this on your computer or whatever device it is now, but now you can get it anywhere. So the big benefit of that is that you don't have to install anything. So you don't need to have this installed on your production machine and then one at your office and then get it on your phone and over here and over here. It's already everywhere. So here in Chrome, I think you just hit Command D, and then that bookmark is added, and I actually don't want that there, so I'll remove it. But put that into your bookmarks and make sure that it's, the bookmarks that get synchronized across all your devices, or put it somewhere where you can get it, so that then the next time you're in the field and you need to open it up on your phone, or maybe you don't have your phone, but you've got your buddy's phone, no problem. You can open it up there. So step number one, bookmark this page. So this is a tutorial, and we're going to learn how to do time alignment first before we move on to the subs. So without getting too pedantic here, this is time alignment because time alignment is for solving distance problem. Later on, which is what you paid for if you signed up for a subscription, but what you really want here are all of the alignments that are stored in this speaker database you're going to unlock later. But first of all, we can still just use this one-to-one preset here for all of our time alignment work. Time alignment work is anything where we don't really need to worry about the phase compatibility between two sources. So if we have two matched speakers, for example, which hopefully is the case in as many situations as possible, we have, the same speaker in every position. So it's really nice when we have, speaker A up for our mains, and then we have the exact same model for our fills, the exact same model for our delays. Now, I know that doesn't happen all the time, but you guys know that makes everything simpler, because if you know nothing about alignment, it is pretty obvious that if you take two of the same quantity and separate them by distance, then the only thing you need to solve is distance. As soon as you change one of those quantities to something else, and now you've got speaker A and speaker B, now it raises a question. Like, are these two phase compatible when they're equidistant? What do I need to do to make them that way? So we're taking all of that off the table and saying, hey, we're just solving a distance problem here with delay. This is time alignment, but very powerful for a lot of the work we need to do. So our first step, it says, is to select the one-to-one preset. So that's what I'm going to do. This is a new name that Ed helped me come up with. Hopefully this is more helpful to understand. This is the thing you click on when you want to do time alignment for fills, delays, relays, that kind of stuff. So this is going to jump us directly to filling out distances here. And should I make this a little bit bigger? Is that better? What we learn here is that we've got this form we need to fill out. I know this is all new if you haven't been through this before. And so I put a couple of definitions here. What does total mean? This is everyone's first question. What do you mean total? Total is every speaker in the room or outdoors, every speaker in the system contributing to low mid buildup in the alignment position. So you want to count everything in your mains, delays, relays, all that stuff. Your tiny front fills, probably not. Those don't contribute a lot to low mid buildup. Maybe one little relay speaker over there. If you have delays, maybe one, probably not big of a deal. But if you have 4 arrays, 2 mains and 2 delays, and all of the arrays have 6 speakers in them, that's 6 times 4, that's 24. So you would put in 24, but we're not going to quite get there yet. So let's keep moving on. And then distance would be the distance from the alignment position to each of the things that you're trying to synchronize, basically. And this trips up a few people at the beginning who are kind of new to alignment. Sometimes people think, oh, do I stand in front of one array? I get this question sometimes. It's totally fine if this is a new process for you. But sometimes people say, oh, do you want me to stand here and measure to this speaker and then walk over here and measure to this speaker? No, we're trying to get everything synchronized at a single position. So we want to stand at that single position, aka the alignment position, listening position, or front of house if that's where you want to do everything. And then we measure to each source so that we get an alignment at a single position. Okay. Okay. So what do we need to do here? Enter 1 in every field and then click Align. You'll see why soon. So say, okay, I don't quite understand what's happening here. I have a lot of questions, but I'm just going to do what the instructions are telling me to do and then click Align. So we'll start with feet and then we can switch to meters later. Okay. So this says, take a look at the delay column. Okay, I've got source, count, distance, delay. Not very interesting, just says 0. The result is 0 because all speakers are equidistant. Equidistant, okay. Right, because I inserted 1 in everything. So source 1 is 1 foot away, source 2 is 1 foot away. So if everything's equidistant, then there's no need for any delay. Okay, this is starting to make sense for me a little bit. Let's make a change, click the back button. Okay. So now it says, try changing the distance of source 2 to 2, then click Align. So source 2, distance, change that to 2, then click Align. Now look at the delay column. The first source is closer, right? Because I made the second source go farther away. And just to refer back here, this is what we're talking about. The sources were equidistant. Now I said, hey, source number 2, you go farther away now. So now we need delay on this first source. And so that's what we're learning here. The first source is closer, so it gets the delay. The first source here is closer, 1 foot closer exactly, so it gets the delay. How much delay? 0.93 milliseconds. This is based on this speed of sound. Why is this a non-default speed of sound? Because I was playing around with the speed of sound earlier. And so I changed it here. But I can go back over here and like reset this to what do you guys use as a default? 1130, 1129, something like that. And then I know I'm jumping around to things that you haven't seen before, but I just want to get back to that final screen that we're at. Okay. So here we are. I've reset my speed of sound, and now we can see that the delay value changed a little bit. So we can see that the speed of sound affects that delay. Probably most important when we're doing this kind of synchronization with full range sources, anything in the high frequencies. Those high frequencies have, those shorter wavelengths. In the low frequency, the speed of sound is probably less important. I hardly ever change it unless we have, some really big distance offsets. And if you have distance offsets that are big enough that you need to change the speed of sound for your subwoofer alignments, then you probably have some bigger system design problems. But we can look at those if anyone has questions about that. Okay, so SubAligner has converted your distance offset to time. So here I have a distance offset of 1 foot. So it's converted that to time, 0.88 milliseconds. So at this point, SubAligner has done nothing amazing, right? This is all stuff that we can do pretty easy with a calculator. We could subtract 1 from 2 to get 1 and multiply that by 0.9 or 0.885 to get something close to this result. What's really nice here, though, is that when we are in the field and we're moving quickly and we just need to be like getting things done and checking boxes off of our list. Sometimes I get confused pretty easily when I'm trying to work quickly and I'm under stress in the field. Sometimes I forget, what was that formula I needed to get that delay value? Or how do I find that offset? Things like that. And so here, just having a box that I have to fill out that basically forces me to do things correctly is already, for me, a big help. So just having a form is pretty nice. Okay, congratulations, you completed your first alignment. Use this one-to-one preset anytime you need to solve a distance problem. That's what we've been doing. When you need to solve a phase problem, click Unlock All Speakers in the side menu to upgrade. Check out the user guide for more. Okay, so we've done this guide and we've gone through it. This is the end of it. And I should update this to say this is the end of the guide, because otherwise you might not know this was the final step. So I'll change that. But for now, I'm going to go ahead and click Don't Show This Guide Anymore. So this blue is going to go away. And now we can keep playing around with this, but put in our own values. So what might be interesting here is to now try this out with something that we know. So I see people do a lot of times is just kind of put kind of gobbledygook numbers in here that don't really mean anything. And then, I just put in matched numbers on accident, didn't I? No, I didn't. And then you get to this final page. Oh, it's not going to let me put a number that big. That's probably for the best. Let me know if you ever want to put in numbers bigger than 1,000. I'll change it. I put in some random numbers and I'm like, oh, this result doesn't really mean anything to me. So when you're checking this out for the first time and just trying to learn it, then put in numbers that mean something to you. So that's why I was forcing you to start out by just putting all ones in here and then just change one thing and see what you can learn from that. See if you think this product is working the way you expect it to. So we started out with all ones, we got a 0, we changed to 2, we went to 0.88 milliseconds. Now let's see what happens if we change to meters. So now we have an offset of 1 meter. That's about 3 feet. So this number kind of makes sense to me. Or if you're used to working with meters, maybe you typically know that, okay, it's about 3 milliseconds per meter or 2.9 milliseconds per meter. Steve, I think Canada uses feet, right? Or is it meters? I can't remember.
Well, we use meters, but it's pretty interchangeable, honestly.
What's funny is that you guys use meters and Fahrenheit, right?
Celsius.
Celsius. Use miles?
No,
Kilometers.
So it's very
okay.
It's very metric unless it's construction or audio, because so much of the audio stuff is coming from like American distributors and stuff like that, with the exception, obviously, like L Acoustic and D&B are not, but the distributors are here, so almost all the instruction is in software is in feet.
Right, and it's funny that you still, you get speakers from all over the world, but they're all still in inches, 18-inch driver, 15-inch driver.
Yeah, that's true.
Okay, meters, maybe this, you can make more sense of this. You say, okay, this makes sense to me. 1 meter offset, 2.9 milliseconds of delay. Great. And so, next step might be to change this number, maybe something like 10 and 10. So if we got 2.9 before, now we expect to get something like 29 milliseconds, right? So now we have an offset of 10 meters. And so we get 29 milliseconds. So I would, if you're doing this for the first time, I would just play around with this for a while. And if you're not familiar with the inverse square law or how distance offsets affect time offsets, then this can be really powerful. And just having a little form here that helps you put those values in and then get results and do it right every time can help you, just avoid making some stupid little mistake where you accidentally put in the wrong value. And I should point out, this is probably where 90% of mistakes can happen in SubAligner and generate bad results for you. It's just by accidentally typing in the wrong numbers. So anytime I have a result that's like, oh, this doesn't really make sense, the first thing I do is go back and look at the numbers that I put in the form. And then it turns out that I put in, one number wrong, or I switch these two numbers in the field. And so I could even probably do better at making these more obvious. Yeah, David, what's up?
Does the alignment and stuff like that have any relevance or adjustments that need to be done with regarding elevation? Because where I live in Western Colorado, all of my events are at 5,000 feet to 9,000 feet.
Yeah, that's really high. So yes, altitude just does change speed of sound, but it's probably one of the least important factors. So if we're at 20 degrees Fahrenheit right now, which I know seems really low, but it's 2 degrees outside here in Minneapolis right now. Of course, you probably wouldn't be having an outdoor event necessarily, but I was just playing around with that. So yeah, let's just see if we leave this set to 20, for example, and we change the altitude to from 0 to 5. Well, let's just try this first. So here at 20 degrees, 0 feet, 50% humidity, we get a speed of sound of 1,075 or 1,074. And if we go up to 5,000 here, it goes from 174 to, see, it barely changed. And honestly, like, I wish there was like some dialogue that said, here's what it changed from 2 to this number. But if we go from 20 to 21, now we see it change a little bit. Now, this is different in different parts of the spectrum. So let's go up to 100 degrees. When I mean spectrum, I mean the range of temperatures. So now let's go up to something very hot and dry. Okay, so now we're at 1160. Now what happens if we go to 5,000? Okay, it changes a tiny bit. Let's go down to the bottom, 0 degrees Fahrenheit, and we'll also keep it very dry. And we'll go from 0, which is at 1051, to 5,000. 1051 barely changes, right? But now let's make it very wet and cold. And now let's try going from 0 to 5,000. Okay, slightly bigger change there. So you can see we just ran a bunch of, ran a bunch of tests here. And even at, these different areas of the spectrum from very cold and dry or very wet, or, all these different places, the altitude seems to be one of the least significant things. But you saw that if I change the temperature, that had a pretty big effect. Next, in terms of priority, might be the humidity level. That has a slightly bigger effect. And then at the bottom would be the altitude here, which has more negligible effect. So it can change it. And if you know your altitude, then you can put that in and have it be more accurate. I do have it on the list of features for the future to basically just grab the ambient conditions from your location. You guys have seen plenty of other apps that will do that. You click a button. It says, insert my local conditions or something like that. And then, as long as you're outdoors, that'll work. But that's why I started carrying this tiny little thermometer with me. It's a great little addition to my bag and just takes a little battery. And not only can I then find the correct, more accurate speed of sound based on what the ambient conditions in my room, but I can also track it over the day. An interesting thing about that then is that if you're doing your synchronization and your delays and your time alignments with SubAligner, then you could do it at the beginning of the day when you are on under some ambient conditions, and then you can change it as you go throughout the day, and you could update those delay times. Now, it would have to be a pretty big change to really warrant, changing anything and possibly disrupting the system. But it's a possibility. I've done it. I think it's pretty cool. Let me just give you a quick demo of that. So we just changed our speed of sound. So let's reset that. If we started the day in the morning, let's say in the morning it's cold and wet because there was, some dampness overnight. The humidity went up. So let's say the humidity is up high, and we're going to stay at an altitude of 0 feet for now. So now we got a speed of sound of 1109. So we'll go back to our history page and we'll run this alignment again. We've got an offset of 10 meters. Now we need to make a bigger offset, I think, to make this more obvious. So let's say that our first source, I guess 10 meters is not an insignificant offset, but I want to make it a little bit farther. So let's jump this up to 40. Okay, so now we have an offset of 30 meters, and it's close to 90 milliseconds. For me, that's still checking out in my head. I have an expectation of like, okay, 30, 3 times 3, that's close to 90. Okay, I'm just sort of like double checking these numbers in my head. So 88.75 milliseconds. That's my delay at the beginning of the day. If I go back over here to speed of sound, and now we're maybe getting closer to the middle of the day or the afternoon. We've got everything set up, sound check time. Let's say that we have a pretty big swing here. Let's say that we're going to go up to 75 degrees, and we'll go down to 20% humidity. Now our speed of sound changes pretty dramatically from 1109 to 1135. So then we can go back to our history and we see, remember we had 88.75. So we can run this alignment again with the new speed of sound, which is always right here just for confidence. I guess I should put this in feet as well. Sorry about that. I guess it's just in meters right now. And now we see this delay has changed a little bit, but something like, let's go back to our history. So it changed from 88 to 86. So not a huge amount, but you can imagine that if you had, say several delay times set up and some of them were quite big and you have these big swings in temperature, if you are the kind of person that wants to update those and keep everything synchronized in the points that you set it, then now you can kind of respond to these ambient conditions, just keep track of them. Where you measure that location, that's another big question that people have, like, where do you take your ambient measurements at, right? You could take a bunch of different measurements and then average them. But, most of us working alone just have one measurement that we take at front of house. So sorry for that digression, but interesting question there. So yeah, I would, if you have time and you have the information from your ambient conditions, I would update the speed of sound, especially if you're doing time alignment in these full range measurements.
Hey, Nathan, just one thing to add. A video I saw by Dave Ratt a few years ago was talking about something similar, not specifically for low mid, but more so for higher frequencies, and how in stadium concerts, as the crowd gets more energetic and lets out a lot of humidity and heat, there's a huge change in the sound, again, mostly for high frequencies. So I could throw that video in the chat right there if anyone wants to check it out.
Yeah. And Dave Ratt's also famous for asking venues to turn up the heat because he says that it makes it sound better. And you should also watch his video about that. But yeah, there's several things going on there. But one of the phenomenons that Jonathan's talking about, I think, is diffraction, rarefaction. I get those confused, but where you have one body of air in the audience, which is different than the air surrounding it, right? So
Right.
it
And so
happens
sound
pretty
waves are
often.
bending. Right. Yeah. Diffraction.
Yeah, sound waves are bending. Yeah, as the temperature around us changes, as we get into the evening, the temperature starts going down, the humidity is changing. But in the audience, it's staying warmer because of all the bodies, and the humidity is different there. And so then the sound will change as it hits that. And I'm not an expert on how to handle that, but I do remember talking about that in some Meyer sound trainings, for example, and talking about how they will angle the PA down more, even though it's incorrect, just knowing that diffraction off of the audience will happen. By the way, if I'm using the wrong word, sorry about that. Somebody will correct me, maybe watching this video later. Yeah, a lot of interesting stuff there with ambient conditions, but this is just a little minor help here, I hope, if you're interested in keeping that stuff synchronized. Okay, so we are kind of getting short on time, and I did want to hit some other people's questions. That was kind of the first steps category. You just do a couple of time alignments there, you see the results, and then hopefully you kind of see initially the power of just being able to convert your distances to time. You don't always need to get out an audio analyzer. You don't need really expensive tools to do this kind of stuff. You don't even need to, set up a click track and then stand there for a while and try to figure it out and get out all these special tools. Take distance measurements, update your speed of sound if you want, and just calculate the offset and convert it to time. And then I have nothing against audio analyzers. You guys know I love playing with audio analyzers. Later, or right after that, once I get my audio analyzer set up, it's nice to go and verify that. But I'll be getting more into this later. Having this tool has made a big change in my workflow because I can skip steps and take some shortcuts when I want to. And also, I feel like that makes EQ go a lot faster. I know I'm not explaining that, but I think that'd be a fun thing to talk about in a future session. Okay, any questions about those first steps, just getting your first alignments done? And just in terms of, I guess I'll stop, but I just want to point out another quick thing. A lot of times people don't know about the profile page, and that's under this menu here. So you've got these menu items here, and then this menu will take you to your profile page. And then that's where you can change any of this information. And then once you have a subscription, a little blue button here will show up, and then you can edit your subscription. I just mentioned that because I get emails sometimes from people saying, hey, can you do this and that with my subscription? And I say, yeah, I can, but also you can do that anytime you want from your profile page. Okay, so I think I saw that Demir is here. Is that right? So Demir asked this really great question. How can you make sure that your subwoofers are perfectly integrated to your mains? And so I'd love to know if anybody has anything they want to say about this. First of all, just, what does integrated mean? What does perfectly integrated mean to you? I think the most basic definition is that it just achieves the design goal, right? So if we're going to add a subwoofer, someone has a reason for that. What do we want it to do? Is it like a low frequency extension? Is it for just like some explosion, and so it doesn't really matter that much? Is it for a specific video or specific effect? A lot of times we're adding subs to extend the frequency range, right? And so we don't want it to sound like a solo component. We want it to sound like the rest of the system. We don't want it to draw attention to itself too much. We don't want it to have such a narrow crossover region, a narrow, integration with the main that we hear two separate sources. So if you're standing too close and they're separated by distance and you sort of hear like, kick, snare, kick, snare, like that. So little things like that make me think about this question of integration. So I don't, let me see if I can open my, I'll just say, Demir, if you're here and you want to give us some more input on that question, you can. Otherwise, I wanted to see, what do you guys think? What does integrated mean? Does anyone have any examples of subs that were poorly integrated or really well integrated? Demir, you're here. Go ahead.
Hi, sorry.
Yeah, what were you thinking of?
So I was building a system for for a friend, a small speaker system, and I use 3 15-inch subwoofers, and I put it in a room around 7 meters by 10 meters, and the subwoofer sounds weird, to be honest. And when I use smart, the phase graph is all over the place.
Sure.
So I was thinking, what did I do wrong, and how can I make sure that the main speakers and the subwoofers can integrate phase-wise, frequency response-wise, or any other criteria, maybe, so that everything sounds at the same time. How do I check if everything is good? Maybe that's the question.
Sure. And these are speakers that you said you're building the system. Are you building the speakers? Or are you just, designing and combining the components?
Well, I picked the drivers. I built the cabinets and put it in stands, and something
Cool.
like that.
So you're actually building the boxes. That's great.
Yeah.
Yeah. So there are a whole lot of questions there about actually building speakers that I don't know anything about, and that, sort of out of the purview context for what we're talking about here, which is just sort of like setting them up and getting them synchronized and getting them everything aligned. But I think we can still have a conversation just in general, like all of these things that you're talking about, properties that we can look at in our audio analyzer and in other measurement devices, phase, time domain, frequency domain, magnitude. When all those things will match when things are well integrated.
Yeah.
Now, at the end of the day, it should just sound good, right? And so,
yes,
you could just, try 1,000 different settings and see which one sounds the best. But what I've noticed, happening pretty regularly is that, or what I have been recommending to people is that, if you're not listening to it, what you can do is come up with like 2 or 3 or 4 different presets and then try deploying those. So, but let's look at the problem that you had in the room, which is that you wanted to kind of answer your own question, which is, why doesn't this sound right? You tried investigating with the audio analyzer and the data was messy, right?
Yes.
Or hard to read. Yeah. That happens all the time. At this point in my life, I've basically abandoned using the audio analyzer for alignments, especially in the low frequencies, just because I so often work in small and medium-sized ballrooms where it's almost impossible to get actionable data. So I'm still using my audio analyzer, but now I'm using it in conjunction with SubAligner, and it's helping me sort of have another alignment that doesn't rely on acoustics, right? Just relies on distance. So if you could show us the data that you got, maybe we could do that on a future meeting, Demir, if you want to, share your screen and show us the data that you got in Smart, then we could all talk about it. A lot of people here have experience with looking at data in audio analyzers. But let's see if we can just give you a few tips here about how you might have gone about this differently. So I think the first step would be to make sure that your two sources are working well before you deploy them in a room and before you start introducing distance offsets. So if I were Jonathan, for example, and I were working at an integrator or a studio designer, what I would try to do is I see the few integrations that I've been to and people that I know that work in integrations, it always kind of surprises me that those guys seem to design their systems and then it gets installed and then they go to do the commissioning. And that seems to be the first interaction they're having with the speakers. And I'm like, whoa, I would have gone to learn about those speakers ahead of time, just because I know through lots of experience putting speakers up in rooms, by the time the room gets involved, we don't know what's going on. There's all these things from the signal chain. Now we're going through the console, we're going through an amp, DSP processor, we're coming out of the speaker, now it's going through the air. Now there's all these interactions. Acoustics is complex, right? So now we're trying to look at all these different things in our audio analyzer. So it's so much nicer if you can start before that, before the room gets involved, get each model of speaker that you're going to deploy and set those up outdoors where there's no room involved. Set up your two speakers next to each other if you can, or just one at a time, then take measurements. So the subwoofer that you're wanting to set up, get that subwoofer, put it outside, get it with your other speakers, set them up side by side. Now try to make those sound good. Even if you're not using SubAligner or any audio analyzer, if you can get two speakers to sound good without the room involved and without any distance offset, whatever you do in that situation, then once you deploy it in the room and you start introducing acoustics and distance offsets, now everything's going to be a lot easier and you'll have confidence because you'll say, oh, I know this sounds good when there's no room and no distance offset. So what's going on here? Well, now there's a distance offset. Okay, we can account for that with time alignment. We can equalize the distance offset at some location. What else is going on? Well, now it's the room acoustics. So can I fix that with EQ? Can I change the design? Can I change the placement or aim? Now you can you've narrowed down the possibilities. But if you just take two speakers and build them and then put them into a room, there's 100 different things that could be going on that are leading to the sound that you don't like. Right?
Yeah. Very true.
So that would be my first tip is to try to separate out some of those questions. Is it the room? Is it your processing? Is it on the electrical side? Is it on the acoustical side? And, you can't turn the room off, but you can take the speakers out of the room. Of course, this is not possible for everyone who's just showing up to do a temporary, speaker installation. Steve just walks into a room. Ed just walks into a room maybe, and he's there for a day or two or a week. You might not be able to do this where you take the speakers outside and you get to know them and things like that. But in your case, Demir, and maybe sometimes for Jonathan, maybe sometimes you can get those speakers ahead of time. Maybe you can take them outside. Maybe you can at least have a little bit of experience with them before the room gets involved and before there's distance offsets, so that you can build up some confidence and say, okay, I know what these are supposed to do. I now trust the manufacturer that they are working well, or in your case, Demir, I now trust that I've built these well. Otherwise, yeah, there's just so much going on. It's really hard to say.
Okay.
Anybody else
Okay.
want to ask Demir any questions or have any suggestions for him about having a nice integration with other speakers when you can't get good data from an audio analyzer? It's a big question. I don't know.
I just think there's so many unknowns. I think there's so many unknowns, and I have no idea what the room looks like or what it feels like or what it sounds like, but it's the room. Like rooms are just troublesome, and like I don't know if you're using a DSP or if you're able to, like, what time alignments you can use. I have found in studios, and Jonathan would certainly know more about this than I do, but I have found that physical deployment of it and getting that as close to a good place as possible before electronic interventions pays higher dividends.
Yeah, I could not agree more with that for sure. And just to reiterate what Nathan was saying, that absolutely, if you can test individual parts of a system, that's totally the way to go. Something we do all the time is trying to separate modal reaction interactions in a room and SBIR, speaker boundary interference response, just to be able to separate those two because they can look so similar just from that perspective. But yeah, for Demir, if you can test each portion of the system, and that means not just the speaker, but the whole system, everything, all of your tools, calibrate everything, test things outdoors, all that kind of stuff to be able to verify that everything makes sense. And then when you put it into the room, all right, now you know what the room is doing versus the rest of your system.
I see. So there has been an advancement after I wrote the question. When I wrote the question, everything was messed up and jumbled up, and I don't know how to read everything. By the way, the system that I designed, everything is fully active. They are driven by analog devices ADAU 1701 DSP chips. So I think I got them quite precise. Every each box. I mean, and then I dump Smart because the data is all over the place. I moved to Open Sound Meter, and then I found maybe I can say an enlightenment event that I can use frequency response, I can use phase, and I can use step response graph to make sure that I'm in line, I'm in time, and I'm in phase. The step response is my last check and balances. But I will need to do some more tests, and maybe I'll email you the result, Nathan, so I can share.
Yeah, that's fine. Or if you want to, feel free to email me, or if you want to, in our forum, in the SubAligner forum, there's a question section here. So feel free to post your question there along with your, measurements and images and your TRF files. And I'm sure everyone would like to get involved in that conversation. I should say also that if you send me the measurements of your speakers, I'd be happy to add them to SubAligner. I've done that for other people. People have their own custom speakers or their custom presets, and then I add them to SubAligner. The easiest way to do that is if you go to tracebook.org and you go to the upload page, then you will find instructions here. There's a little video series that you can watch, and there's a measurement procedure linked to right here. And that will guide you. And this has all the instructions done with Smart. So if you're using Smart or Open Sound Meter, I have separate instructions if anyone is using RAW and you're kind of starting out for the first time, I have a separate list for that. But this is the best way to upload your measurements and then get them into SubAligner. And then the next time you're doing a deployment in a room, then you'll be able to come into SubAligner and choose my Demir fantastic speakers and do an alignment with those.
Okay.
Okay.
Thank you.
Yeah, you're welcome. So Mark Emerson wrote in, and I don't think he's here now, but he said he's interested in calculating subarrays. So this has been proposed to me a couple of times with SubAligner, and I would be happy to do it. I'm just curious if you guys think you would use it. How are you currently calculating delay times for building? Are you building directional arrays? Are you building gradient, infire, subarc? And when you do, how do you calculate those delay times? Yeah, so I'll just put that to you guys. Are any of you actually deploying directional arrays? And if so, how do you design them? Oh, you're muted. Oh, sorry, Ed, I thought you were going to start talking, but you didn't. Okay, I'm going to assume that if no one's talking, that you're probably not deploying directional arrays, which is fine. I use them all the time, wherever I can. It's the main design tool that we have when, most subwoofers are omnidirectional. If you're using some kind of directional elements, that's another question. But most of the time, out in the field, I'm running into omnidirectional subs. So the only way I can have any control over where that sound goes so that it doesn't just bounce around all the walls is by creating a directional subarray. And I won't spend too much time on it here since it doesn't seem like anyone here is using those arrays. But there's an opportunity that SubAligner could help you calculate those, because the way that you calculate the delay time for a directional array is by knowing the operating bandwidth. And the only way to really know their operating bandwidth is to know how you're going to use it with the mains, because you could just read the spec sheet, but then if you get into the field and you turn the sub way up or turn it way down or whatever its relationship is with the other speakers, that defines the highest frequency, that changes the overall bandwidth, that changes the design and therefore the delay. And since we already know some of that information in SubAligner, because we have all of these relationships built in the database, then it would be pretty easy to calculate those delays.
Just to jump in for a quick second, when I'm doing stuff like that, most of the time I'm just using the manufacturer's, software. Obviously, they all have their own, which is annoying to learn 7 different ones, but it is what it is. I haven't done too much with, we were doing acoustic modeling in CAT acoustics and also ease. And I haven't really put those both together. It's kind of a complicated procedure. So kind of do the acoustics on one side, the electroacoustics on the other.
Yeah, and those softwares are powerful. And the manufacturer presets, well, I guess it's different depending on what you're doing, but the manufacturer presets are always for an inline gradient. They can't give you a preset for, are always for a gradient stack, if that's what you're building. They can't give you a preset for an infire array or for an inline gradient because the delay is determined by the distance, but they can give you one for an inline gradient stack. In that case, the delay is always the same. And therefore, it doesn't really make sense to build a calculator for that, because the manufacturer is going to know exactly what the distance is. And you really either need an audio analyzer or some specific distance. So I'm just pointing out that that's what those presets are often for.
Well, okay, I'm not sure. I'm talking about like the software for DMB, where you're mapping out and putting the subs where they actually go and dialing in gain and delay and all that stuff. Is that what you're referring to as well?
Oh, I'm sorry. I guess I was just thinking of the preset in, sometimes I'm not sure about in a D&B amp, but presets that you would load in an L acoustics amp, for example, there's a cardioid preset. And when you have a cardioid preset, most of the time it's for an inverted gradient stack. But no, I'm sorry. You were talking about actually doing designs in array calc and then actually doing placement. And so you can do then any kind of array you want.
Yeah, exactly.
Yeah. So then the question still comes, if you're doing any kind of array you want, how do you decide on that design? How do you decide on the placement and then the electronic settings, the delay times for those elements?
Yeah, great question. Experience, asking a lot of people in our company and talking to the manufacturer. They usually have a decent place to start, but I find a lot of times they're kind of copy and pasting, and so it's our job to kind of
Okay,
look
so
at
they
the
have
whole
some kind of
menu.
template for you.
Mhm.
They have some kind of template for you to start from.
Yeah, yeah, we'll work with them, and they'll kind of take a pass at designing it, and then we'll just sort of collaboratively work together to figure it out.
Yeah, that's great. And I cut off somebody else. I think Steve or Ed was going to talk. I can't remember.
Well, I was just going to say I am using like directional subs in a lot of places, but I'm not always responsible for doing that. So the tool would be interesting because the situation that I run into where things aren't perfect. Now, sometimes they're great, and I have a system engineer to take care of all that for me, and that's a luxury, and that's nice. But the other situation is I'm working with someone who maybe doesn't know how to do that, or when it's festival season in the summer here, and people get reassigned and PAs get reassigned. And so I end up on a site where the PA that arrived was the one that was available this morning. So I'm I'm not prepared for any of it. And the system tech that was going to be on that site had to go save some other thing. So now all of a sudden it's like, so guess what? Front of house guy, you're also the system tech today. And so go ahead. And so in those situations, I find myself like I actually have used SubAligner in those situations last summer because, as you know, there's no time. So it's really helpful. But being able to, I have just resorted to not doing a directional sub because I don't have time to confidently figure it out.
Sure. And there's another situation that I hear from friends and colleagues pretty often where you walk into a situation where someone else has set up the sound system. You need to get going quickly, but you see that they've done something like a directional array or a sub arc or whatever, and you're kind of wondering, do they know what they're doing? Is the question, right? And so you don't want to just say, Jonathan, I see you set that up, but do you know what you're doing? You want to kind of just have a quick conversation with them and say, hey, what's your design here? Or what, can I just look at your output processor? Or what delay times did you use on these? And if you can already kind of know what values to expect, then if they say something that, falls within your expectations, then that can be really helpful. If they say something that falls way outside of your expectations, then okay, I probably need to go and take a look at this at some point. Or, oh, they said the thing that I kind of expected. That great, they probably know what they're doing, and then you can kind of move on. So, yeah, I think it's a good tool for that, just kind of verification.
Mm-hmm.
Otherwise, Jonathan says, "Oh, I put in X milliseconds." I'm like, okay. Cool. So this last question then, unless anybody has any more, is David, you said you were talking about this venue. So tell us more about this, David. You have some question here about subwoofer placement, and it looks like a concrete face on like a stage. Is that what's going on? It looks like David just dropped off. That's too bad. He was here the whole time, and then I just got to his question. I don't know if you guys want to try and say anything about this question. it sounds like he's trying to place subwoofers and there's some sort of, boundary issues. I'll take one stab at it, David. If you're watching this later, I'm wondering if you're worried about reflections from those surfaces. I have at least 2 videos about this because at this point, when I'm deploying subs, especially moving quickly, and I don't know what that reflection is going to do, I use the 3-to-1 ratio, like we often do for microphones. And so if the reflection from that boundary is ever going to be within that 3-to-1 ratio, and therefore, arriving and still be energetic within 10 dB, and also, arriving late enough that it's creating comb filtering, creating a cancellation, then I'll just push the subwoofers against the wall and make them couple with the wall. And that's my only trick that I have found to be helpful, is that instead of wondering, if that boundary is going to do something, I'll just couple with the boundary, and then no more reflection from that, at least that one boundary. Okay. Well, this was fun. Thank you guys for being here. Chatting about alignment and talking about these topics is one of my favorite things to talk about. It's a thing that I think a lot of sound engineers skip over because they don't quite understand it, or they just sort of like to paper over it and say like, oh, if I can't hear it, then the audience won't, or if I don't quite understand it, it's probably not that big of a deal, or but I think it's a critical and often overlooked topic, and so I've been doing a lot of writing and talking about it over the last few years. And in fact, a lot of you are probably sick of hearing me talk about it, but it's really interesting for me. So thank you guys for being here. Let me know what you potentially like to talk about in the future. We can keep the discussion going in the Discord. If you're ever trying to look for the forum, it's right over here. So you click on forum, it will take you over to here. Otherwise, thank you guys for being here. And I don't know when the next one is going to be, but when it is, I will send out another email. So you either need to be on the SubAligner emailing list or in the Discord, and I'll make an announcement there. All right. Thanks, everybody. Good to see you.
Thanks, Nathan.
Thanks, Nathan.